this exam question comes from Year 12 Maths Methods, VCAA, VCE Official Exam Paper, 2015, Exam 2. Section 2, Question 4, Extended Response Question. Question 4 said, an electronics company is designing a new logo based initially on the graphs of the functions fx equals 2 sine x and gx equals 1/2 sine 2x for x between 0 and 2 pi. These graphs are shown in the diagram below, in which the measurements in the x and y directions are in meters. So that's one graph, and that's the other graph. The logo is to be painted onto a large sign with the area enclosed by the graphs of the two functions shaded in the above diagram to be painted red. A, the total area of the shaded regions in square meters can be calculated as A integral of sine x dx between 0 and pi. What is the value of A? How do you do such a question? Well, they want you to basically work out all of this yellow area. Well, the red curve is fx equal to 2 sine x, according to the question. And the green curve is gx equals 1/2 sine 2x, according to the question. To work out that yellow area between the two curves, you just have to use shaded area equals integral of top curve minus bottom curve. Now, that's equal to, if you work out that yellow area there, it is equal to the integral of the top curve, which is 2 sine x, minus the bottom curve, which is 1/2 sine 2x dx. Now, because all that just works out that yellow area there, then to get the other yellow area, you got to multiply it by 2. Then the next thing that we need to do is the following. That now total shaded area is equal to 2 times integral of 2 sine x minus 1/2 sine 2x respect to x between 0 and pi. Now, the problem with this, I mean, that's correct. I mean, that does give you correctly the yellow area between the two curves. But the problem with this is that in the question, they want the final answer to be like that. That is, they want the final answer in terms of A, integral of sine x between 0 and pi. But that is, they want the final answer to be in terms of one sine function. But here we got an answer with 2 sine functions. So how do you reduce these 2 sine functions to one sine function? And how do you change that 2x down to x? Well, to solve this problem, we've got to take the following approach. Now, we can solve the above problem by taking the following approach. In the above graph, we have shaded area A and shaded area B. What we can do is we can move shaded area B to the left so that shaded area B is directly below shaded area A, as shown in the following graph. And by doing that, we get a graph like this. Remember, the trick that we use here is that we can move shaded area B to the left, and when we do that, when you think about it, all of that ends up being that. So now we've got the top curve and the bottom curve. And now we need to find this total yellow area. To find this total yellow area, we have to realize that this total yellow area is equal to 2 times the yellow area that exists between the pink red curve and the x-axis, times 2. So by knowing that, we can go like this. Total shaded area is equal to shaded area A plus shaded area B. And that's equal to the yellow shaded area between the red curve and the x-axis, which is given by integral of the equation of the red curve, which is 2 sine x, between x equals 0 and x equals pi. And because we want to find the total yellow area, then that will be twice as big. That's why we put a 2 there. Done. Then, every time you got an integral, and inside the integral, you got a constant which multiplies everything else, we can take that 2 out as what we've done here. And the next thing that happens is that because is this 2 times 2 is 4, and you end up with 4 integral sine x between 0 and pi, and that matches up perfectly with what the question wants you to find, which is a integral of sine x between 0 and pi. And so you can see that A equals 4. So question A is done. What is question B? What is question B about? Question B is about the following. Question B is about the following. The electronics company considers changing the circular functions used in the design of the logo. Its next attempt uses the graph of the functions fx equals 2 sine x and hx equals 1/3 sine 3x for x between 0 and 2 pi. On the axis below, the graph of y equals fx has been drawn. On the same axis, draw the graph of y equals hx. Okay, well, they want us to draw the graph of hx equal to 1/3 sine 3x. I did that in red here. Now, please note, of course, as you should know, for sine curves and cos curves, the period is 2 pi on n. Therefore, because we got a 3 in h equals 1/3 sine 3x in front of x, then you're going to put n equals 3. So the period is 2 pi on 3. So the period up to here of this one curve here is 2 pi on 3. Half of 2 pi on 3 is pi on 3, and half of pi on 3 is pi on 6. So that's why we get here pi on 6, 2 pi on 6, 3 pi on 6, and 4 pi on 6. And that's one period. And then to get the next period, we go 5 pi on 6, 6 pi on 6, which is of course pi, 7 pi on 6, and 8 pi on 6. And we get the second period. And then to get the third period, we just continue on 9 pi on 6, 10.6, 11.6, and then 12.6, which is, of course, 2 pi. And also we have to consider that because the graph of hx equals 1/3 sine 3x has got 1/3 in front of sine, then the amplitude is 1/3. So you make the amplitude 1/3 there, and of course down here negative 1/3, and you draw the red curve. And question B has been done. Now we go on to question C. State a sequence of 2 transformations that maps the graph of y equals fx to the graph of y equals hx. Now, transformations basically is just a fancy way of saying changes. So what the question is really saying is, state a sequence of 2 changes that maps the graph of y equals fx to the graph of y equals hx. How do you do C? Well, C is done in the following in the following manner. C is done in the following manner. Firstly, they're saying to you, what changes do we have to do to go from the fx curve to the hx curve? Well, the changes that we have to do to go from the fx curve to the hx curve are the following. Firstly, we've got to get that 2 in front of sine x to go down to 1/3. How do you do that? Well, by multiplying the whole thing by 1/6. Because as you should know, 2 times 1/6 is 1/3. To achieve that, we're going to do step 1, shown in green, which is multiply the y ordinates by 1/6. That is, y equals 2 goes to y equals 3. So y equals 2 will go down to y equals 1/3, I'm sorry. That is, in other words, every time you multiply the y ordinates by 1/6, what are you doing? You are dilating in the y direction by a factor of 1/6. Therefore, as a result, we obtain the graph of y equals 1/6 times 2 sine x. And what's 1/6 times 2? It's 1/3 sine x. So we get the graph up to now being 1/3 sine 3x. So what's the next step that we've got to do to make the 1/3 sine x go to 1/3 sine 3x? Well, the only difference between 1/3 sine x and 1/3 sine 3x is that there's that 3 in front of x. How do you get that 3 in front of x? Well, because the 3 is only in front of x, you got to divide the x values by 3. So that now is step 2. You got to say x values divided by 3. Now, when you think about it, using grade 5 fraction theory, when you work out x values divided by 3, you're really working out the following. Multiply the x ordinates by 1/3. So when you multiply the x ordinates by 1/3, then the period of 2 pi goes to period of 2 pi on 3, as shown by the red curve, which is what they want you to get to, which is the hx curve. So therefore, when you multiply the x ordinates by 1/3, then what are you doing? You are dilating in the x direction by a factor of 1/3. And as a result, we end up with what they want you to end up, which is hx equals 1/3 sine 3x. So they are the two changes that you got to do so to go from the graph of f to the graph of h, as requested by the question. Now we move on to question D. What is question D about? question D refers to the following. The electronics company now considers using the graphs of the functions kx equal to m sine x and qx equal to 1 on n sine nx, where m and n are positive integers, with m greater than or equal to 2 and x is between 0 and 2 pi. The part 1. Find the area enclosed by the graphs of y equals kx and y equals qx in terms of m and n if n is even. Give your answer in the form am plus b on n squared, where a and b are integers. How do you do such a question? Well, you take the following approach. Firstly, in the question, they mention k equals m sine x. And they say in the question that m is greater than or equal to 2. So let's make, for example, m equal to 2. They say also in the question that qx equal to 1 on n sine nx. And they say in the question that n is even. So let's say, for example, that n equals 2. So you end up with, for example, qx equal to a half sine 2x. So if you, for example, graph the red curve kx equal to 2 sine x, and then you graph the green curve, which is qx equals a half sine 2x, which is the green curve, then you end up with that diagram there. What they want you to find in this question is find this total yellow area. Well, you find this total yellow area by saying that the total shaded area between the red curve and the green curve is equal to the integral of the top curve minus the bottom curve. Now, when you do that, you end up with the following. The total yellow area is equal to the integral of the top curve, which is 2 sine x minus the bottom curve, which is the green curve, which is a half sine 2x between x equals 0 and pi. And by doing that, we find the yellow shaded area between the red curve and the green curve between x equals 0 and x equals pi. To get the total yellow area that you see in this diagram, you got to realize that that yellow area is the same as that yellow area. So to consider the whole yellow area, you just have to multiply it by 2. Now, in the question they say that in the question we made, for example, m equals 2, and we made, for example, n equals 2. Now, if we now change that 2 back to original m, and we change these two 2's to original n, then we will get the following. 2 times integral of m sine x minus 1 on n sine nx dx. Now, from that, we can integrate. So we say 2 times Integral of m sine x is negative m cos x minus 1 on n. Integral of sine nx is negative cos nx. Because of that n in front of x, divided by n, and is between 0 and pi. Then we say 2 times negative m cos x. Then we say negative times negative is a positive, and we say cos nx on n squared between 0 and pi equals 2 negative m cos. Now, at which point we can, in the middle of the integration, put in x equals pi in there, and you get negative m cos pi plus cos n pi on n squared. Like always, in the middle of these types of integration questions, we put a minus, and then we put x equals 0 in there, and we get negative m cos 0 plus cos n times 0 on n squared. Now, that's where we add in the overall calculation 1. That's where we add in the overall calculation 1. Now we've got to do a bit of a side calculation because we need to work out what is cos n pi when n is even. How do you work out that? That is shown on the next page. You know that from your circular functions theory that the unit circle looks like that. And the unit circle, as the name suggests, has got a radius of 1. So that means it's going to be x equals 1, x equals 0, x equals negative 1. And because the unit circle has got a radius of 1, then that's going to be y equals 0, y equals 1, y equals negative 1. And you should know that that's angle 0, pi on 2, 1 pi, 3 pi on 2, and 2 pi, and so forth and so forth. Now, you should know that when it comes to cos, the cos is always the horizontal distance in the unit circle. So for cos nx, where n is even, then we will get that's 0, 2 pi, 4 pi, 6 pi. In these situations here, as you can see, n is always even. N equals 2, n equals 4, n equals 6. So therefore, from the above unit circle, we have cos n pi. For cos 2 pi, the horizontal distance is 1. For cos 2 pi, we go around the circle to the angle 4 pi, put a stick there, and cos is the horizontal distance, and cos 4 pi is this horizontal distance there, which is 1. And then we do the same thing for cos 6 pi, and you will see that it still gives you 1. So therefore, we can conclude from these observations that every time n is even, cos n pi is always 1. That is, when n is even, cos n pi is always equal to 1. So knowing that, we can now go back to overall calculation 1, which was that, and do the following. Well, here we were up to overall calculation 1, which was here, which was 2 negative m cos pi plus cos n pi on n squared minus negative m cos 0 plus cos n times 0 is 0 on n squared. Now, with with the calculations that we've just done, now we can continue on with that. Because with the calculations that we've just done, we have concluded that when n is even, cos n pi is always 1. So therefore, wherever you see cos n pi, you put in 1. And we end up with the following. 2 negative m cos is, now, at which point we got 2 negative m and cos pi. So therefore, we get 2 negative m cos pi, which is, we saw from the unit circle that cos pi, when we got cos pi, you go to pi and put a stick there, and cos is the horizontal distance, and it's negative 1, plus cos n pi. We've just seen that in this part of the question, cos n pi is always equal to 1 on n squared minus negative m times cos 0 according to the unit circle. When the angle is 0, you put a stick there, and cos is a horizontal distance, which is 1, and that ends up being 1 plus cos 0, which is 1 on n squared. Then we can clean that up by doing the following. 2 negative m times negative 1 is m, plus 1 on n squared minus negative m times 1 is negative m, plus 1 on n squared. Then that comes out to 2 times m plus 1 on n squared, and then negative times negative is a positive m. Then negative times positive 1 on n squared is negative 1 on n squared. Then that comes out to 2m, collect the like terms, m plus 1 on n squared minus 1 on n squared, and that comes out to 2m plus m is 2m, and then 1 on n squared minus 1 on n squared is 0 on n squared, and therefore 2 times everything inside these red pink brackets, 2 times 2m is 4m, plus 2 times 0 is 0 on n squared, and we have answered the question. Now we go on to the next part, which is part 4D, part 2. Now, what is 4D, part 2? Well, in 4D, part 2, they go on to say this: find the area enclosed by the graphs of y equals kx and y equals qx in terms of m and n if n is odd. Give your answer in the form am plus b on n squared, where a and b are integers. The way you do this question is to take the following approach. They tell us in the question that kx equals m sine x. And they tell us in the question that m is greater than or equal to 2. So let's say, for example, that we make m equals 2. So in that case, k will be equal to 2 sine x. They say in the question that qx equals 1 on n, sine nx. And they say in the question that n is odd. So let's say, for example, that we make n equals 3. So as a result, q will be equal to 1/3 sine 3x. In such a case, as you should know, the period for any sine or cos graph is equal to 2 pi on n, where in this case, n equals 3. So the period is 2 pi on 3. So therefore, that's equal to 4 pi on 6 using grade 5 fraction theory. So therefore, if we graph the red pink curve, k equals 2 sine x, we end up with this pink curve there. Then if we graph the graph of qx equal to 1/3 sine 3x, which is shown by this green curve, then we will have amplitude of 1/3 as shown by this green curve, and the period will be 2 pi on 3, 2 pi on 3, pi on 3, pi on 6, so it's going to be pi on 6, 2 pi on 6, 3 pi on 6, 4 pi on 6, etc. Now, in this question, they want you to find the total yellow shaded area between the red-pink curve and the green curve. How do you do that? Well, you just use the same integration calculus formula that we used before, which was total yellow shaded area is equal to the integral of the top curve minus the bottom curve. Then we take the following step. That the total yellow shaded area is equal to the yellow shaded area between the pink curve and the green curve between x equals 0 and x equals pi. And that's given by integral of the top curve 2 sine x minus the bottom curve 1/3 sine 3x between x equals 0 and x equals pi. And to get the total yellow area, like we did before, you got to multiply it by 2. Now, because we know that m equals 2 and n equals 3, then wherever there's an wherever there's a 2, you replace it with m, and wherever there's a 3, you replace it with n. Again, wherever there's a 3, you replace it with n. Then we continue on with our calculus. The integral of m sine x minus 1 on n sine nx is the following: negative m cos x minus 1 on n. Integral of sine nx is negative cos nx on n between 0 and pi. Don't forget to multiply by 2. Then it's 2 times everything inside these pink highlighted brackets. It's negative m cos x, then negative times a negative is a positive, cos nx, n times n is n squared between 0 and pi. Then, like we do in the middle of these integration questions, we put in x equals pi, then we put in the minus, and then we put in x equals 0. Then we put in x equals 0. And we obtain the same calculus formula that we got in the middle of the previous part, the part 1. But from this point onwards, we take a slightly different path. Here again, we've got to work out what is cos n pi when n is odd. To work out cos n pi when n is odd, we're going to do a little bit of a side calculation. So that's where we add in the overall calculation too. Now, We know from a unit circle that that's, of course, 0, pi on 2, 1 pi, 3 pi on 2, 2 pi, then 5 pi on 2, 3 pi, 7 pi on 2, 4 pi, and so forth and so forth. Now, when we want to work out cos n pi when n is odd, then when n is odd, then we're going to end up with 1 pi, 3 pi, and 5 pi, and etc. So from the above unit circle, we have the following. We have the following. That when we consider cos n pi when n is odd, then when n is 1, we're going to end up with cos 1 pi. We go to work out cos 1 pi from the unit circle, we go to 1 pi, put a stick there, and because cos is always a horizontal distance on the unit circle, then that horizontal distance is -1, -1. Then the next time when n is odd will be when n equals 3. So to work out cos 3 pi on the unit circle, we go to the angle 3 pi, put a stick there, and cos is always the horizontal distance, and that horizontal distance is -1, -1. So cos 3 pi is -1. And then the next time when n is odd is when n equals 5. So you put n equals 5, there you go, you get cos 5 pi. To work out cos 5 pi on a unit circle, you go to 5 pi, and you get to angle 5 pi, put a stick there, and cos is a horizontal distance, and the horizontal distance is -1. So from all that, we can see that when n is odd, then cos n pi is always -1. And that's why I say here, that is when n is odd, cos n pi is always equal to -1. Now go back to overall calculation 2, which was here. And overall calculation 2, which was here, says that total shaded area is equal to 2 -m cos pi plus cos n pi on n squared minus -m cos 0 plus cos 0 on n squared. Now that we know from the calculations and from the considerations that we've done on the unit circle, that for cos n pi, when n is odd, then cos n pi is always equal to -1. So by knowing that, we can continue on with the calculation. 2 -m cos pi from our unit circle is -1 plus cos n pi, as we've just seen, when n is odd, is always -1 on n squared, minus -m cos 0. Cos 0, what's cos 0? Cos 0 from a unit circle is 1, and plus cos 0, which is 1 on n squared. And then we can clean that up now algebraically. So it's going to be 2 times everything inside the pink highlighted brackets. -m times -1 is m, plus -1 on n squared, -m times 1 -m, plus 1 on 1 squared. That then 2m minus 1 on n squared, negative times everything inside these brackets here. Negative times -m is positive m. Negative times positive is -1 on n squared, equals 2 times, collect like terms, m plus m is 2m, and negative 1 on n squared minus 1 on n squared is negative 2 on n squared. And then we say 2 times everything inside these pink highlighted brackets. 2 times 2m is 4m, and 2 times negative 2 is 4 on n squared. And by doing that, we would have covered D part 2. And by doing that, we would have done the whole of question 4.